All right, thank you for watching. This video is going to be on basically an introduction, at least it is for my students. It may not be an introduction for you, but I'm going to go through some, I don't want to say basic, well, yeah, they're basic geometric proofs. Now, for my students, we have made a list of reasons, um, whether it be addition property, symmetric or subtraction property, symmetric property, definition of linear pair, definition of midpoint, of the things that they have gone through class. And I suggest that if you are a student going through a geometry class, that if your teacher's not making you a list, that you are taking notes and making a list of all of the theorems, postulates, definitions, properties that you've gone through, so that when it comes time to do a proof, you have kind of this summarized list of what you could actually be doing to solve this proof. Um, as a teacher, I definitely don't expect my students or anybody for that matter to have memorized every definition, postulate, theorem, property out there, all right? Especially while you're working and you're getting confused and frustrated while working through a problem, then you remember even less. So good to have a list. Now for these ones, I'm going to go through step by step. This might be a long video. Um, bear with me. So yeah, let's get into it. So top right corner, the top right corner is always given. You always have to start with something. You're always given something to begin the proof. And we will be given that the measure M stands for measure and the symbol stands for angle. So the measure of angle BCD equals 80 degrees. All right. Now what we want to prove is that the measure of angle DCA is equal to 100 degrees. This is what we want at the very end. All right. At the very bottom left corner, we are going to want that. Now, I honestly don't know if I'm going to have to add on another cell. I don't know. I have not solved these. I have no key next to me. So I don't know. We'll find out. I didn't leave myself much room. So hopefully I don't need to add more than one cell. But what I do, the thing that I always do after I put in my given is I always go straight to the diagram and I look. And what I see when I look at this diagram is I see two angles that form a linear pair. They form a line. They are supplementary and they are adjacent, and therefore they form a linear pair. Now, what's special about a linear pair? Well, a linear pair are two adjacent angles whose sum is 180 degrees. So we could say that the measure of angle BCD, and now I don't want to do DCB, I want to use BCD because that's how it's written right here. So they already have said that BCD is 80 degrees. All right, that's what you were given. Now, what I want to say is that the measure of angle BCD plus the measure of angle DCA, not ACD, all right, not the rock band, because look at the order that this is written in. This is DCA, so I want to do DCA. DCA equals 180 degrees. Why? Well, that's the definition of a linear pair. All right, definition of linear pair. Okay, well, what is special about these two things? Well, they're the same. They're literally the same thing, right? They are literally the same. So is it possible, is it okay for me to substitute, Sharpie will come off. Is it okay for me to take this 80 degrees and substitute it in right there. I mean, measure of angle BCD is 80 degrees. Is it okay for me to replace this measure of angle BCD with 80 degrees? Yes. Substitution means you're allowed to plug in, replace, substitute a known thing, in this case, an angle measure, for something it is equivalent to. Well, this is equivalent to 80 degrees, so let's substitute in 80 degrees. Substitution. Okay, getting closer. Well, now, if you envision this just to be an x, and this is 80 plus x equals 180 degrees, how would I solve for x? Well, I'd subtract 80 from both sides. So I don't want it. So if I subtracted 80 from both sides, minus 80 minus 80, well, what's 180 minus 80? 100. Okay, and 80 minus 80 cancels out, so I'm just left with the measure of angle DCA equals 100 degrees. Oh, that's what I was trying to prove. And the reason I'm allowed to subtract 80 from both sides is the subtraction property. Subtraction property. And more specifically, the subtraction property of equality. Obviously, my students would be typing into this, so they wouldn't run into the issue of running out of space, because the cell would just keep getting bigger. Right, so you got 4 steps. Step 1, step 2, step 3, step 4. Solved. All right, we proved it. Proven. Therefore, QED. Okay, move on to the next one. So this next one is saying C is the midpoint. So let's try and fit this all in. So C is the midpoint of AB and CB is congruent to DE, period. Okay, so C is the midpoint of AB and CB is congruent to DE. That's all given. All right, we are going to try and prove that AC is congruent to DE. What we want to prove is this little piece is congruent to this little piece. Okay, now I'm going to use this midpoint. What is special about a midpoint? Well, a midpoint is a bisector. It's a segment bisector. A midpoint, the middle, means it bisects the segment that it's in the middle of in half. So this piece is congruent to this piece. So I can say AC is congruent to CB. Definition of a midpoint. All right, definition of a midpoint. AC is congruent to CB. Okay, well, I want to prove that AC is congruent to DE. And I know right now that CB is congruent to DE. So could I substitute DE in for CB? If CB is congruent to DE, can I substitute in DE right there? Yes, I can. Now there's also, if you've learned the transitive property, that if AC is congruent to CB and CB is congruent to DE, then AC is congruent to DE. Transitive property totally works. I've not yet gone over that with my students. I've gone over substitution with them, and you are allowed to substitute in a value that is either equal to or congruent to the value you're trying to plug it in for. So I can substitute that in, and I would get AC is congruent to DE, and that would be substitution. All right. That would be, I think, the quickest way, and this can either be substitution or the transit property, whatever you have learned. I think that's the quickest way to do it. You really don't need these cells below it. Now, is that the only way to do it? No, there's longer ways to do it, but I think that's the quickest way. Is since C is the midpoint, this is congruent to this by the definition of the midpoint. And then since we have proved, we already knew that CB was congruent to DE. And then we just proved that AC was congruent to CB. That meant that we could substitute DE in for CB, since we know that this is congruent to this also, based off of what we were given. Right? So they're all three congruent. They're all interchangeable. You can substitute them in for each other now that we know, that we proved it. Okay. Let's keep going. This one's kind of a long one. I don't know if there's a shorter way to do it, but the way I would do this is, first off, I would start off with the angle. Angle 3 is congruent to angle 4, given. And we want to prove that this angle and this angle are congruent. Well, what I know, looking at this diagram about this angle and this angle, is they form a linear pair, right? They form a linear pair. So what is a linear pair? Well, a linear pair are two angles whose sum add to 180 degrees. So I can say the measure of angle 1 plus the measure of angle 3 equals 180 degrees. I can also say the same thing about angle 4 and angle 2. So the measure of angle 4 plus the measure of angle 2 also equals 180 degrees, because they are also a linear pair. All right, so these are both, well, it should be the definition. Definition, linear pair. And it is also for that step 2. In reality, if I had enough room, I'd just put those both in the same cell, in the same line step. So definition, linear pair, definition of a linear pair. Anyways, they add to 180 degrees. Okay, well, if this, let me do a different color. If this is all equal to 180 degrees, can't I substitute it in for 180? I know it's equal to 180. I know it's equal to 180, so can't I substitute in for 180? Yeah, why not? Let's do it. Let's substitute that sucker in. So we get the measure of angle 1 plus the measure of angle 3 equals the measure of angle 4 plus the measure of angle 2. Substitution. Right? This equals 180, so let's just substitute it right on in there. Again, the transitive property, if this is equal to this, and this is also equal to this, then this is equal to this. Substitution transitive property, either or. So we have a step though that we kind of need, right? We've done step one. In reality, I would kind of combine this to be step two, and then we've done step three. Now I know something special about angle 3 and angle 4. I know that angle 3 and angle 4 are actually the same angle. They're congruent. And I know they're congruent because I was given that they're congruent. However, this is talking about congruent angles. This is talking about adding together and setting equal angle measures. So what I need to do here is I need to take step one. I need to take step one. And you could have did this right off the bat if you thought of it. But what I need to do is I need to take step one and I need to change it to be the measure of angle 3 equals the measure of angle 4. And the reason that is the definition of congruence. By the definition of congruence, if something is congruent, it is also equal. And if something is equal, it is also congruent. So the definition of congruence. Okay, now what is the point of that? What is the point of that? Well, the point of that is I have two things that are equivalent on both sides of this equal sign in step 3. I have two things that are equivalent on both sides of this equal sign, which are equivalent. Can't you just get rid of them then? Right? Can't I just, like, if I had A plus 2 equals 2 plus B, wouldn't I just subtract 2 from both sides and get A equals B? Right? I would cancel them out. Yeah, you can. So can't I just cancel out this? Well, what is canceling out? Subtraction. We want to subtract it away. We want to get rid of it. We want to take it out of the equation. Let's subtract it. So you'd be left with the measure of angle 1 equals the measure of angle 2, and that would be subtraction property of equality. All right, of equality. My students, I just let them put in subtraction property. More specifically, subtraction property of equality. Okay, we're super close. We are super close to what we're trying to prove. We're trying to prove that angle 1 is congruent to angle 2. Super close. Well, in step, technically, it would be step 4. This would be step 5. To go from 1 to step 4, I use the definition of congruence to change the congruent to an equal. Can I change the equal to a congruent? Yep. Yes, I can. I can do that. All right. You can do the opposite of. It goes both ways, right? Equal can be changed to congruence. Congruence can be changed to an equal sign, and they are all by the definition of congruence. All right. Definition of congruence. Done. Now I did not need all these extra steps, so don't need these steps. I don't know what's going on with my line there, but don't need them. All right, do not need those steps. So we ended on step 6. Finished it off. All right, in reality, well, yeah, no, because I did step 2 right there. So I did combine that. So yeah, 6 steps. And what did we prove? We ended up proving that that is congruent to that if these two angles are congruent, which would make sense, right? If I was to go back up here and I was to put, let's say, 50 degrees here and 50 degrees here, well, mathematically, if this is a linear pair, this has to be 130. And mathematically, if that's 50, this also has to be 130. So It works out. Like it should work out. You just have to go through and prove it. Tedious, long, I get it. I feel like most students understand this a lot more quickly than they understand this. Moving on. That's problem 3. I might, you know what? I'm going to split this video up. I'm going to do 5 problems in this video, just for the sake of how long it'll take to download an hour-long video. So, angle 2 is congruent to angle 3, given. All right, that stuff is given. Okay, so I am given that is congruent to that. I want to prove that angle 1 is congruent to angle 4. Now, looking at these angles, what is special about this angle and this angle? Hopefully, everybody is in their head saying they're vertical. They are vertical, Mr. Walters. Vertical angles. Yes, they are vertical angles. And vertical angles, by the definition of vertical angles, they are congruent. So I can say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Definition of vertical angles. Okay, definition of vertical angles. This is congruent to this, and this is congruent to this. Well, what can we do now? I want angle 1 is congruent to angle 4. So if I want angle 1 is congruent to angle 4, and I know that angle 2 is congruent to angle 3, can I take this? Can I take angle 4 and substitute that in for angle 3? And can I take angle 1 and substitute that in for angle 2? Well, angle 4 is congruent to angle 3, so that checks out. Angle 1 is congruent to angle 2, so that checks out. So let's just do a double substitution all at once and get angle 1 is congruent to angle 4. Substitution. And you don't need this. That one was quick. All right, that was a short one. Yeah, I think I actually did that one quicker, with one step less than I did it when I went over it in class. So I think I did substitution and then substitution a second time. You can just do it all at once. Angle 3 can be substituted with angle 4, plop it in. Angle 2 can be substituted with angle 1, plop it in, and you get it. That's it. That's what it wanted. That's what you're trying to prove. Perfect. Awesome. Okay. Let's move on to number 5. And then I'll cut this video off there. So angle 1 is congruent to angle 3. Yeah, let's just start off with what we're given. Always, angle 1 is congruent to angle 3. Given. Looking, and we want to prove that this angle and this angle are supplementary. But what we can prove right off the bat are these angles form a linear pair. And by the definition of a linear pair, they add to 180 degrees because a linear pair are also supplementary. So I can say that the measure of angle 2 plus the measure of angle 1 equals 180 degrees. Definition of a linear pair. Don't know I capitalized the P. I'm going to roll with it. Definition of a linear pair. Okay. Well, I have addition, equal sign, talking about the measure, and here I have a congruence. That's an issue. I need to take step 1 and I need to change this. I need to change this from a congruent symbol to an equal symbol using the definition of congruence. So I can change this to be the measure of angle 1 equals the measure of angle 3. Definition of congruence. All right. Perfect, perfect. Well, that means that I can take this beauty right here and I can substitute it in for the measure of angle 1 because it is equal to the measure of angle 1. So I can substitute it in for that, which is going to get us very close to the end result that we want. So we get the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Substitution. This would be step 3, this would be step 4, step 5. Okay, well now I know, now I have angle 2, the measure of angle 2 plus the measure of angle 2, no, the measure of angle 2 plus the measure of angle 3 equal 180 degrees. Well, these are obviously not a linear pair, right? This angle, measure of angle 3, and this angle are obviously not a linear pair. So them adding to 180 doesn't say that they're a linear pair. But it does say that they're supplementary, right? The definition of supplementary is that two angles add to 180 degrees. So I can say now that angle 2 and angle 3 are supplementary angles. And that is the reason for that is the definition of supplementary. All right. Perfect. Solve that. That's what we tried to solve. We wanted to say that angle 2 and angle 3 are supplementary. They are supplementary because they add to 180 degrees. And we know they add to 180 degrees because we substituted in this measure of angle 3 in for the measure of angle 1 because they're equal. And we know they're equal because we said they're congruent. Okay, or we were given that they were congruent. So I really hope you guys watch part 2. Yeah, I'll see you there. Thank you for watching part 1.